Hey everyone, so in this video we want to use what we learned so far to create a really cool effect, and that is we want to grow roots along an object. And we will face an interesting problem and learn a new node that is super powerful for everything we will do in the future in simulations, and that's the SOP solver. But let's not go too fast. So what we have here is our statue here of Mars, and as usual when I bring it in, which is an alembic of course, I should always check the scale, and we can see it's a pretty big statue, maybe a little bit too big. So let's scale this down maybe to something like this, should be fine. Thanks Tommy. And then of course a convert that we can probably work with this, otherwise we will end up with a packed alembic object. So now we can start. And what we want to do first is we want to create particles that basically move along our surface, and then we want to use the trail node to connect them so that they feel like a root. And we create a pop network to save a little bit of time. And the problem is if we run this right now, and of course my scene starts at 1001 so that I have a pre-roll. If I run this, then the points will be emitted everywhere. But you know, we said that the roots should be growing upwards. So ideally I want them to start down here. That's relatively simple because all I have to do is somehow cut away the area that I want to use. I can do this with a clip, for example, but I can also do it with a Boolean. So a Boolean and a box will allow me to define the area I want. Oh, by the way, we could also have used a group node and a blast. So many different ways of doing this, but I think I take the Boolean approach. And what I want to do is now I want to not cut away the ground, but I want to do the opposite. I want to have the intersection. And if you think about it, what I want the points to emit from is not below our statue. So this should go away. So let's make the box a bit smaller. And also we don't want the points to come from, from the cutting area here inside of the stem or inside of the feet. So in other words, I don't need those intersection areas to be closed. I want them to be open. How could I do this again? Well, I could just say that my Mars here should not be considered a three-dimensional object, but actually a hollow hull. And I can tell my Boolean by saying, please treat the first input as a surface, and then it will not create intersection faces. And now you can see I will not have a geometry where points will be scattered on the intersection areas here or underneath my statue. And this area here seems like a good area where the points should come from. Again, you could have done the same with a group node and a blast, or maybe two clips for the upper part and the lower part. Many other ways of doing this. This is just one. And now what I get is that the points only come from here, from this area, and that seems like a good idea. Okay, so now we want them to move upwards, right? We want them to grow. So what we can use here is some kind of, mechanic or force that moves it upwards. A couple of things to think about here. We could use a pop force. We could also use a pop wind. Or we could use maybe a gravity that we turn around. So many options we have here. We could even use a pop axis force if we want, which would allow us to, add an additional movement, maybe a rotational movement, which would be interesting. So many different options to move my points upwards. Which one do I take? Well, one argument I would give here for the pop wind is that it will never be faster than a maximum speed that we define. If we would use a pop force or a pop axis force or even a gravity, they will all constantly accelerate our points. So the points will be faster and faster and faster. And that means our growing would speed up over time. There's nothing fundamentally wrong with that. You can totally do this. But I think the pop wind is a better choice here because it is a wind force, which means the points will reach a certain speed and then will never grow faster than that, or never will move faster than that, which feels a bit more natural for something that is growing. But if for some reason you wanted to use another force, like I said, for example, the pop axis force, which creates a rotational movement, then you can stop it from constantly accelerating by simply bringing in a pop drag that would fight that constant acceleration and at some point would make the points keep a certain speed. So you can still do this in a more complex way by combining it with a pop drag. Let's keep it simple for our case. So I hope this made sense. And this is why we use a pop wind here. And of course, we want to move them upwards. And this is basically the maximum speed we define here. And the air resistance is the acceleration. Let's see how this looks like when we turn on the real time. And then it looks like this. And yeah, let's start with that. But of course, what we can see, we have way too many points. So let's make sure we use less than that, way less actually. Maybe let's try 50, I don't know. Maybe that's still a bit too many, I don't know, maybe 30, I don't know. And yeah, I think that's not a bad start. Now, they move upwards now, but it's a bit boring, right? So as usual, to make the whole thing more interesting without having to think too much about it, let's add a little bit of noise. We could add an additional pop force here to add a noise, but remember the pop wind has a noise as well, so we can just increase the amplitude here. And let's see if the swirl size is what we want. Maybe a little bit smaller. Yeah, that's not too bad. And now I feel like they've become a bit too fast, so let's lower our amplitude a little bit, and maybe here our wind velocity as well. You know, this is something you have to dial back and forth to find something that works. This feels kind of natural speed-wise to me for something that is growing, so we don't want it to be too fast. Let's go with this for now. Okay, cool. So now we have our points moving for the growth effect, and as we've seen before, we can now just use a trail. In this case, we're lucky because points are not dying, and we'll probably not see them dying, so we can go the simple route using a simple trail. Maybe we have to change this later, we will see. So let's change it to connect as polygons, of course, so that they actually become curves and make them a bit longer. And then we can see the problem with that. It actually creates literally polygons or faces. To fix that, we have to turn off close rows, and then we actually get curves. They are still a bit too short, so maybe we increase the trail length to something really high, like 1,000 or something, and then they will be really long and actually look like roots. Cool. So this is what we've seen before. This is how we can create a growing effect, you know, of plants or something. Now the problem is though, what we wanted actually to grow this along our geometry. So if we look at our geometry again and merge the two together, we can tell that inside of our simulation, there is no reference to our object. We only take the lower part as the source. Now, of course, what you could do is adding a static object, but this wouldn't actually solve the problem that it's not growing along the surface. We need to find a way somehow to make sure that those roots will only be growing on the surface. Now, you might remember a node that does that for us, and that is the ray node. The ray node allows us to stick objects to another object. Let's try that. We take the points that come out of our simulation here, and it seems like why I shouldn't see the Mars object anymore. This is a bit weird. And what this is, unfortunately, when I look through my PopNet, I should expect only to see the points, and I still can see the curves and my Mars object. And even if I rewind, that's the case. So unfortunately, even in 2022 with Houdini 19, we still have our display error here, which is really frustrating. And since I installed the Houdini Labs, I can just go to help and then set reset viewport. If you don't have that option, then you can always just close the current scene view and open a new one. There you go. I wish this problem would have gone by this time. I don't know why it's still there, but so be it. So here we're back to what we wanted. We only see the points coming out of our PopNet. And what we want to do now is we want those points to stick to our Mars. So those would be the input of our array, and then the Mars should be our collision object. And when we run this, and actually let's put this into a tray, then we can see it better. Let's see how this looks like. And you can see something is happening, but it's not really what we wanted. We have some jumps here. What's going on? It's simple. I forgot that the ray node by default will take the normals into account. Normals of what? Well, of the points. And what are the normals of the points? They are kind of weird because they use the normals of the source geometry, so they're all over the place. That's not what we want. We don't want to use the normals. We want to find the closest point on the surface of our Mars, and this is minimum distance. And now you can see we don't care about the normals anymore. The points are actually jumping to our surface, and then it looks like this. You can see that the points seem to stay on the surface, but they create those weird lines all over the place. This is pretty ugly. It looks more like spider webs or something. Now the problem here is you should not try to do this after the simulation, because what we're doing right now is we're taking points, as you can see here, those points, and stick them to a surface while they're animated in a completely disconnected way of the surface. They don't even are aware that the surface was there when they were simulated. And then you can't expect that the end result of then sticking it to the surface afterwards will look okay. And the solution for this actually is to do this process that we did here after the simulation, during the simulation. And let me quickly explain to you in a graphic the difference between the two concepts. So our current approach is to take a simulation of points that weren't even aware that the statue was there during the simulation, and just after they are already moved, to stick them to the surface of a geometry. The problem is that now it's basically completely random where the points are, and the points that were found are kind of, logically not connected. They're just randomly on the surface, which result in this weird thing here, and this big jump in the connection, because the movement of the original points were completely disconnected of the basically characteristics of our geometry. Now the alternative is that we do this not after the simulation, but during the simulation in every single simulation subframe. So we take a point and correct it, so to say, to jump to the surface of our geometry. And now for the next frame, this will be our starting point. So this point will again completely randomly move based on the noise in our pop wind, and then stick again to the closest surface. And for the next frame, this will be again the starting point, and it goes on like that and on like that. And this will result in a much closer behavior than doing this just afterwards, when there was never any connection in place during the simulation. And we will actually see that this will look much better in a second, but the question is now, how do we do this? How can we use this ray node in a simulation? Because in here, when I type ray, there is no ray node, because a ray node only exists on the SOP level. And this is now the main trick here. We can use a SOP solver to bring in every node that we've learned so far in SOPs, and we can use them during a simulation by just dropping it in here like this. And the SOP solver is actually just a package, so to say, where you can go in, and on this level here, we are back now on the SOP level, and we can use everything that we've learned so far, for example, the ray node. And the logic here is, and we ignore the impacts, feedbacks, and relationship geometry, this is a bit more complex, but this here is interesting, the DOP geometry. Everything that is happening during the simulation comes out of this node. So what comes out of this node is points, and we can just use them like before as a first input. And how do we get our mass in here if it's somewhere else? Well, since this is the top level again, we can just use a simple object merge. Now, of course, we can now again search for our geometry here, but as we've learned, the best way is to create a proper output node so that we can find the point we want, or the output we want. And at this point here, this is where our mass comes out. So let's call this out mass. And personally, I make this red, but you don't have to, of course. And then it's clear that something will use this, and we will use this in here in the object merge. We just look for out, and then we find here our out mass. There he is. And we take this as a second input. And remember, we have to change this to minimum distance. And now if we run this, we can see how the points are constantly moving just like ants along the surface. So again, it now corrects itself, so to say, every frame, and this will result in a much nicer look. So let's get rid of this ray. We put this inside, and now when we use a trail to connect our points, it should look much better. And unfortunately, it's a bit hard to see. Well, something like this. And here you can see no jumps anymore, and it looks clean and nice, and there are no problems anymore. One small note here before we move on though, make sure that your render and display flag is always on the last node that is calculated. So if you accidentally have your render flag here or your display flag and then simulate, then you will get the wrong result, because then out of your SOP solver here, the statue will come. This is very dangerous, and that actually happened to me a couple of times. So always make sure either to have your display or render flag on the last node you actually want to calculate, Or even better, create an output node, because then it makes sure that whatever you have your display flag on, out of your SOP solver will always come what is connected to the output node. Very important. Let's finish this off and make it a bit easier to see by actually thickening our roots here, because this is now a bit hard to see because they're so thin, they're just curves. And we know one option would be a polywire, which is a very simple node as long as we lower the wire radius and maybe increase the divisions. Then it looks like this. But maybe another solution to make this look nicer is a sweep node, because the sweep node has the advantage when we set it to round tube that we can, and we lower the radius again, of course, that we can actually control the thickness over time. Now we have a couple of problems here, and that comes as usual probably from some kind of normals. So there are the normals. So before we go into a sweep, I would recommend deleting attributes that we don't care about. And for now, I think we don't care about any attributes, so let's just delete them all. And now you can see it's much cleaner. Not perfect, but much cleaner. And the cool thing about using the sweep node is that we can use the built-in scale function. Since this is supposed to be a root, let's make it thinner at the ends, so it actually looks like it's growing. So something like this maybe. So here you can see the ends will go thinner. And here you can see it looks really like a growing effect. Let me maybe turn the background dark. I think it might be easier to see then. There you go. And this gives a really nice effect. Now, I think we're pretty good so far. The only thing I would change to make it even more interesting is to maybe either increase the points, a few more roots would be nice. And another thing very important to me is I'm not happy with the amount of chaos. I want a bit more. So let's increase the amplitude of the noise in the pop wind and maybe lower the swirl size. And hopefully we should get then a bit more detail. And let's make our statue a bit darker. It will also be easier to see then. So something like this. And of course we want to see the sweep, not the curves. Then it looks something like this. Yeah, and you can see because I increased the noise that the movement is a bit more, chaotic. And so in my opinion, it looks a bit more interesting that way. Cool, and you can see, yeah, this is pretty nice. Maybe what we could do is change the color to finish this. And of course, you can change your version in all kinds of other ways. Lowering the speed, increase the amount of roots, feel free to experiment with your own versions of this. This is just a quick setup. You can create all kinds of interesting variations of this. So, but one last word before we finish. A lot of beginners instantly figure out that there's one problem with this setup, of course, and that is intersections. Now, unfortunately, solving intersections in a setup like this is really complicated because basically the way we did it, the points are not aware that they, that there are roots or that even that there are other points. So there are techniques to solve this, but it's really complicated and not suited for beginners. And this is why I leave this out, and we, can just accept that there are certain things that we just have to hide a little bit. But if you're interested in that, I'm linking in the questions below an article from CG Wiki that explains this problem, and you will see there that this is not actually beginner friendly. This is something you should probably look into when you're a bit more experienced with Houdini much later on. So nonetheless, I still think it's a pretty cool effect, and certainly what we did is we learned about a super important node, and that is the SOP solver that allows us to use any SOP node inside of a simulation, which opens up even more options than we already have. So I hope this is helpful. Thanks very much and see you later. Cheers.